Today's notes are on slope or rate of change and graphing equations. The slope is the steepness of a line or the rate of change. You'll hear of it referred to as the rate of change when we're dealing with word problems. There are two ways to calculate the slope. The first is by taking the rise over the run. The second is using the equation y1 minus y2 over x1 minus x2. When it's talking about rise over run, and these are my 2 points, the vertical distance is my rise, and the horizontal distance is my run. Next, we're going to look at the different types of slopes and what they look like. The first one is a positive slope. The positive slope will rise to the right. A negative slope will fall to the right. If a line has a slope of 0, it is a horizontal line. And an undefined slope occurs when there is a vertical line. To practice, we are going to find the slope between two given points. So I'm going to make the first point my x1 and y1 values, and the second point my x2 and y2 values, and I'm going to plug them into the formula for slope. So I will have y1 minus y2 over x1 minus x2. If I simplify this, the numerator becomes 7 over 5. The denominator becomes negative 3 over 2. If I'm trying to simplify by hands, we then need to remember that in order to simplify a fraction being divided by a fraction, we will first unstack it. So I have 7 over 5 divided by negative 3 over 2. Then, because I can't divide fractions, I am instead going to multiply by the reciprocal. To give me a final answer of negative 14 over 15. Please pause the video and try example 2 on your own. Notice that you will not be able to simplify because you will have two variables left in your equation. The next part of our notes asks to decide which of two lines is steeper. To find this, we are going to take the absolute value of the slopes. The larger number of the two will be our steeper slope. So I'm going to start by finding the slope of line 1. And I'm going to use the same formula, y1 minus y2 over x1 minus x2. And I'm going to simplify it. 1 minus a negative 2 turns into 3. 1 minus 0 is still 1, which gives me a slope of 3. I then take the absolute value and find that my answer is still 3. Next, I'm looking at the slope of the second line using the same formula. y1 minus y2 over x1 minus x2. 4 minus negative 2 gives me 6. Negative 1 minus 2 gives me negative 3, which gives me an answer of negative 2. If I take the absolute value, I get a positive 2. Because the larger number represents the steeper slope, my steeper slope is line 1. Please try this for yourself with example number 4. After you have finished, we're going to look at deciding whether or not lines are parallel, perpendicular, or neither. Parallel lines have equal slopes, while perpendicular lines have opposite reciprocal slopes. So for example 5, we're going to start again by finding the slope of each line using the same formula. y1 minus y2 over x1 minus x2, which will give me negative 4 over 12, which will simplify to negative 1/3. If I find the slope of line number 2 using the same formula, y1 minus y2 over x1 minus x2, I get negative 9 over negative 3, which gives me a positive 3. For a slope to be an opposite reciprocal, I must flip the fraction and the sign must change. So for one slope, I have negative 1 over 3. I can think of line 2, if I need to, as being 3 over 1. The sign has also switched, which means that these are opposite reciprocal slopes. Which means that my two lines are perpendicular. Please pause the video and try example 6 on your own. We will be looking at example 7 tomorrow in class, so we're going to scroll down and start on the back page looking at graphing using intercepts. This should be a review, so we'll do one example together and then you'll try one example on your own. To graph using intercepts, we need to first find the intercepts for each graph. To find the x-intercept, we find where the graph crosses the x-axis. To find it, we plug 0 in for y and solve for x. So for my x-intercept, I'm plugging 0 in for y, and I'm going to solve for x. 0 plus 2/3 x leaves me with just 2/3 x. And I remember that if I want to get rid of a fraction, I'm going to multiply by the opposite reciprocal. Which means that I'm left with just x on the left side and 6 on the right. My ordered pair is then, for the x-intercept, is then that number, comma 0, because I plugged in a 0 for y at the start. So I could move over to that point and plot it on my graph. I then want to look at finding the y-intercept. To do this, we plug 0 in for x and solve for y. So I will have y plus 2/3 times 0 is equal to 4. 0 times anything is 0, so I'm left with y is equal to 4. For the y-intercept, my x is always 0, and I use the value I found for my y-coordinate. If I plot 0, 4, I now have 2 points on my graph which I can connect to form my line. And we want our line to be straight, so we should use a straight edge. Please pause the video and try example 9 on your own. The last thing is on the notes is slope-intercept form, and that is the equation y is equal to mx plus b, where m is equal to the slope and b is equal to the y-intercept. This is denoted by the ordered pair 0, b. So to graph using slope-intercept form, we first need to solve for y. Which means that I'm going to start by subtracting 1/2 x from both sides to get 2y is equal to negative 1/2 x plus 4. I'm then going to divide every term by 2 to get y by itself. To get a new equation. We know that the b value, which in this case is represented by 2, is our y-intercept. We should also see from the definition above that we can write this as the ordered pair 0, 2. That's where we start on our graph. I then need to remember that slope is rise over run. Because it's negative, I will fall and then run over. So from here, we have to fall 1 and then run 4. I can continue this pattern until I have a few points, making it easier for me to graph. Again, I want to connect my points with a straight edge. To complete the picture. Please try example number 11 on your own.